Hello, this is the genuinely approachable Sudoku for the 30th of January 2024. 30th? No, sorry, 29th, I think. Yes, the genuinely approachable Sudoku for the 29th of January. It is Half a Cake by Philip Newman, who claims it is their half birthday. So happy half birthday. So Sudoku rules. Normal Sudoku rules apply, so we place the digits 1 to 9 in every row, every column, and every 3x3 box. Ratio pairs. Digits in cells separated by a black dot, such as these two, must have a ratio of 2 to 1. So one digit must be double the other. You must have something that looks like this, or maybe this, or something like that. No negative constraint, meaning that, dots without cells without black dots can have also a ratio of 2 to 1. So something like this is totally fine. Alright, and it is said that this puzzle is going to be a bit harder, so we'll spend some time on it. Alright, so with that, let's begin solving. Now I do see a lot of straight, streaks of dots such as these, and actually these digits, I think these digits are quite forced, because in a 9x9 Sudoku, the only digits that you can have beside black dots would be 1 2, 2 4, 4 4 8, or 3 6. These are the only pairs you can have. And so in these streaks of 3, digits may not repeat, and therefore you can't have the 3 6 pair, because if one of these had 3 6 in it, the other digit would not be able to have 3 or 6, and therefore it would not be possible to fulfill a line with the 3 6. Which means that all streaks of 3 actually must come from the set 1, 2, 4, and 8. We can say stuff about these two, which must be from the set 2, 4, and 8, because they cannot have one of them. And in fact, 2, 4, 8 forms a straight increasing pattern of, increasing, doubling each. So the middle cell is always a 4. Depending on which direction it is, the middle cell will always be a 4. And we can place those digits down. And now 1, 2, 4, 8 looks at this, and therefore this cannot be 1, 2, 4, 8 and must be from the 3, 6 set. This one also, this pair also can't be 1, 2, 4, and 8, and therefore must be 3, 6, which we can disambiguate by this 3 here. So that's 6, that's 3, that's 6. Now this pair, this set here, and this set, and in fact we can probably mark all the sets to make it slightly easier for us. They cannot be sorry, not 3. They cannot be 3, 6, so they must be 1, 2, 4, 8, which does give us a very interesting quadruple here. Now the digits that are beside 1, 2, 4, 8 have to themselves be 1, 2, 4, 8 as well, because 3 and 6 are self-contained. They can only contain 3 and 6. And in fact, I can tell you that has to be 3 and 6, and the reason why is because 1, 2, 4, 8 only has 4 digits in the set, and so these 5 cells cannot all have 1, 2, 4, and 8 in them. Therefore, this set cannot be from 1 to 4 and must be from 3, 6. We can do something similar here where these two cells cannot be 3, 6, cannot be 1, 2, 4, 8, so they must be 3, 6. That cell is therefore 3, 6 as well. Alright, so we have all the dots to work with. Let's start removing some, I guess. Those can't be 4. In fact, that can't be 4 either. The middle cell can never be 1 or 8, because 1 only has one partner, which is 2, which you can't put on both sides. And same for 8, so all the middle cells, like so, we can remove 1 and 8 from, which does in fact form a 2, 4 pair, so that's nice. This digit can in fact be 1, 2, 4, 1 or 8 though, because those digits can be the same. Right, okay. What next? Oh, well, this digit can't be 1. Yeah, the middle digits can't be 1 or 8 either. So this can't be 1 or 8 and must be 2, which must be next to 1 and 4 because it can't be next to 8. So we get a 1, 4 pair here. In fact, the 2 sees that cell, so that's 8, meaning that's 2. This 8 now removes 8 from that cell, which means something. I think. I'm not sure what it means. I see, but 1 cannot be in those cells, and the reason why is because 1 will always be next to 2, and these 1s, if they were 1s, would put a 2 in those cells, which is incorrect. So those digits can be 1, forming a nice 2-8 pair. Actually, like a quadruple 2-8, which is quite cool. Alright. Now what? We can remove 2 from there. Yeah, now we can definitely see that 8 will go with 4, which goes to 2. And 2 will go with 1, which goes to 2. So that's how it will work out. We can also say things about what is not next to the dots, right? Because 5, 7, and 9 all cannot be next to dots. If you try to put them onto dots, hopefully you can convince yourself that it is not possible to place any digit opposing it. So we can put 5, 7, and 9 here. I think similarly we can do the same here. These are 5, 7, and 9. This is not 5 and that is not 9. Okay, now what? Well, I can say 3 and 6 do not reside in those cells, and we know those cells are not 3 and 6 either by our pencil marks. So those two cells must be 3 and 6, which forms a 3-6 pair, which does form a vertical 3-6 pair, so maybe that's useful. Alright. Is this very similar to that? I feel like it might be somewhat similar. Not sure though. Okay. This contains a 7 and a 5 plus 1 digit from this set here. Alright, well I can say 5 goes in one of those cells by Sudoku, and 5 goes in one of those cells by Sudoku. So that may be helpful. Not entirely sure that it will be, but maybe. Alright. Yeah, I'm not seeing much to do here. Maybe let's think about that cell. That cell might be more important. If it's a 2, we know it has to be next to 1 and 4. If it was 4, it needs to be next to 2 and 8. No, but 2 and 8 are next to 1 and 4. And then 1 and 4 will be next to 2 and 8. Which doesn't remove any candidates at all. So no. I think we need another. I see. This 2 and those 2s look into this box, which means that none of those can be 2s, so 2s must be in one of these cells, which might mean something. If this was a 2, it would need to be next to 1 and 4. But if this is a 2, you need to double twice, right? You can't half twice. So this would need to be 2, 4, or 8. So removing the corner center pencil marks, we get, if this is 2, this must be 1 and 4. If this is 2, then this must be double, which means 4, and this must be double, which means 8. Alright, not much done there, but alright. I think that's decent progress. Okay, you know what? I should also note that these long chains have to contain 2 and 4 in them. And the reason why is because in any, set of 3 consecutive digits in that set, you will include 2 and 4 always. So we can say, I guess, that those cells must have 2 and 4 in them. Which means that, I don't know what that means. 2 could be there, which is fair enough. So, well, this 4 does remove 4 from that cell, which doesn't do much, but I guess it's something. Alright, 5. Oh, I was gonna say 5 in this row, but no, 5 could be here or there. So it's not very useful. Oh, this 3 sees that cell. Why didn't I not see that? That's just 6, that's just 3. Okay. Well, I guess I cannot spot, but okay. 3 doesn't see much. No, I don't think it does. 6 has to be one of those cells, which means nothing. Yeah, that might be the end of this trail. Oh, I can put 3 in this box though, because those 3s see those cells. This 3-6 pair stares into that, so 3 must go there, which means that's now 6, that's now 3, that's 6, that's 3, that's 6, that's 3. Alright, all resolved. I can put 3 in this box now. 3 has to be there in this box. I think we can do the 6s as well, maybe? Yeah, 6s look in those cells, so 6 goes there. 6, yep, 6 has to be there in this box, which means that in this box, 6 goes here. And I think that gives us all our 6s. Okay, cool. These cells must be 5, 7, and 9 because, you know, everything else is already part of a quadruple or a digit. This cell can be 5, that cell can be 7. Okay, not very helpful, but sure. We need 1, 4, and 8. 7 has to be one of those cells, which pushes the 7 to one of those cells. Let's mark that, shall we? Let's just mark that for convenience sake. Not sure if that's gonna help us in the future. It might. It might. Okay, I can put those digits in. Those are 5, 7, and 9 once again. That digit is not 5. But now we don't have much else to work with. Although we do have a 5, 7, 9 pair here. So, so in fact we don't have 3 in this box. This 3 must be there. So this is part of a 1, 2, 4 triple, huh? Yeah. Oh, and oh no, I was gonna say this is 2 and 4, so that's 1. That's not true. That is not true. I could probably do something here though. I think I could do something here. Because this set over here doesn't have to contain a 2. It does, right? Because if it contained the 4, if it contained the 4, it would need to be 4, 8 or 4, 2. But this pair cannot be 4, 8 and therefore must be 4, 2. Yeah. So we're saying if there is 2 here, then there's no way to complete this set. So 2 can't be there. Which means 2 is one of those cells, so that's not 2. So in fact, I think this 2, 4 might speak for this cell now, which can't be a 2. Maybe. If we had a 2 here, we need to go 4, 8. But if it's a 2 here, it would need to be next to 1 and 4. Which forms a pair, I guess. So 2, 4, 8 or 2 with a 1, 4 pair here. Alright, that was a lot less fruitful than I expected. Okay, these 4 digits are part of a 1, 2, 4, 8. Oh, I could also say that 2 is in one of those 2 cells, which removes 2 from there. Although I would have to remove 2 from here first, so I guess what we did right. That's a 1, 2, 4, 8 quadruple, so this is 5, 7, or 9. A very nice 5, 7, 9 triple here. Okay. Again, not very much to do, so... Have we gotten all the 3s? We have... Oh, sorry, there's a 2 4 pair there. Why didn't I see that? So that's not 2 or 4, that's just 1. Oh, alright, so that's not 1. That forms a 2 4 pair, which means that cell must be... Well, it's either 1 or 8 then. Because if it's 2 4 in one direction, it goes down to 1 or goes up to 8. Which now means that this cell, if it's 1, it has to be next to 2. If it's 4, if it's 8, it needs to be next to 4. Which does form another 2 4 pair, so this is not 2 or 4, it's 1 or 8. Okay. Did not actually see this one. So 8. 8 is one of those 3 cells now. I don't know. Alright, this is definitely taking me a very long time to spot. What a genuinely approachable Sudoku though. So approachable, jeez. Okay, give me a bit of time here. I know this is entirely a skill issue on my part. So hang tight. I will say though, whatever digit this is, it's always an extreme, which means those digits are always going to be the same. Right, so maybe we can do a bit of coloring and say, well, where does this digit go? It can't go there, and it has to go there. Ah, so what this means is that those digits have to be that digit, which cannot be 1 8 anymore. So that does form a 2 4 pair, another one actually, which means that is not 2 4, it's 1 or 8. Now that forms a 1 8 pair, which removes 8 from that cell. And I guess we can mark those digits as different then. Which doesn't do much, but alright. That one is blue. Yeah, okay. And that's about it. Alright. Oh, I just realized this 2 8 pair stays at that cell, which can't be 2 or 8, so that's 4. That's 1, that's 4. Which must be next to 8 because 1 needs to mix to 2. This 4 means that's 2, and that's 8, which needs to mix to 4. So all those cells are 4. All those cells are 2. That cell is no longer 2. This 2 needs to mix to 1, because it can't be mixed to 8. The remaining digits are 5, 7, 8, 9. Which, alright, I think we'll look at this instead, which is 5, 8, and 9. 5 can't be there. Alright, this 2 means that's 8, so that's 2. Alright, it is sort of unraveling. Again, as I said, a massive skill issue. That 1 means that's 4. And this is 1 because 8 was up there. Right, so now we need to place 8 in this box. This 8 sees that cell, so 8 goes there. This is 5, 7, or 9, but can't be 5. We need a 1 in one of those cells. Therefore a 1 in one of those cells. Which we can't put down yet. 1 is in one of those cells in this box, which stares at those cells, so 1 must go there. Which we also know from the 2, I guess. Now we know that in this row 1 cannot go there, so 1 goes there. Those digits have to be 8 and 5. And this 8 disambiguates that. 5, 8. This is not 5, so 5 must go there in this box. Those digits are 1 and 9. Which we'll fix later, I guess. This is a 5 or 7. This 8 removes 8 from that cell. So this is again 5, 7, or 9. Right. So that digit, well, this 5 disambiguates this, so that's 7. That's 9. That's 5. Those cells are not 5 anymore. In fact, this does form an 8-9 pair, which we can resolve. So that's 9, that's 8, that's 7, that's 9, that's 5. This is a 9 by this 7 over here, which resolves this, which resolves that. Those cells now can't be 9, which should be resolvable at some point. That cell is 5 or 7, which means we have a 5-7 pair here, so that is just 9. That's 1, that's 9. 1 in this box can only be there now. 9 removes 9 from that cell. In fact, 9 in this box can... Oh, 9 in this box is right there. Those 9 see that cell, so that's where 9 goes. That's a 7. That's 5. That's 5. That's 7. So that's 5. That's 7. That's 5. Alright, finally. This is 7 and 8, which we can resolve. That digit is 4. Those digits are 2 and 8. Solving the puzzle in 19 minutes and 12 seconds. Alright, well this took a lot out of me. I don't know if it's because, you know, I just did not do this well, or if it's because I'm tired or whatever. But yeah, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.